In this video, we introduce the programming paradigm for Robot Pew. You can find this lecture in the RoboGen's website. You can go to the Story of Pew, Book 3, Growth. In the first chapter, Hello World, Robot Pew. And the third section, the programming paradigm of Robot Pew. The programming paradigm of Robot Pew basically is a really simple three-step programming called observation, think, and action. Every program in either Robot Pew or in the gamepad controller, they follow the same paradigm. In the observation phase, basically it is Robot Pew will collect all the data. The data is either the command is received from the gamepad or the sensor values, and the sensor value including the sonar distance, including the gyroscope, the tilt information, and acceleration values in x and y/z axis. All those also temperatures, the sound levels, and the light intensities. And if it got I2C interface, it will collect the servo positions, the motor power, yada yada. Once it get those information, then you move to next phase called thinking. It is based on all the data it's collect from in the last phase, and Robot Pew will do calculations, and if it depends on what state it's in. For example, in autopilot mode, robot will look at the data streaming from the distance sensor and make decision which direction should go. Once it make decisions, for example, moving forward at what speed and turn left and right at what angle, and it will go to next phase. It is called action, and robot will execute those computed action lists and start move. And since we mentioned in previous sessions, a robot has one microbit and a gamepad have another microbit, and different microbit will run different cycles of observation, think, and action because they focus on different purpose. The robot program focus on robot um, safety and navigation and planning and that. And for the gamepad controller, it's mainly focused on capture the human actions, also capture the external environmental uh, changes, something like that. And so they run different kinds of their own different loop of observation, thinking, and action loop. And there are more details about the observations and thinking and actions. I think is really in abstract level, and we have to work on each detailed feature and or tasks. Then you will understand why this observation, thinking, and action is so important. If you want to write a good program, you have to make sure each steps the robot do the right thing. For example, in the observation phase, you have to make sure the data you collect in this phase, it is correct, and is also most recent one. For example, if you mess up the information from the left leg, misuse with the right leg, then robot will fail. If you take a data like a distance data from 2 seconds ago to make decision, then the robot will do some wrong decision. And in the thinking part, we have to learn algorithm design, like those sorting algorithms, searching algorithms, then like a feedback loop and optimization problems. So basically, we need a lot of knowledge and hands-on sessions to understand how those algorithm works. And in the action phase, you have to make sure all the planned actions got executed correctly. Is any mistakes or actions or deviations during the actions, you have to report to a robot and trigger the corner exception handling. And for example, in the middle of the run, you want robot 10 left, but something's going on. Could be there's obstacles in front of it or some motor fail, and if that thing happens, you have to write your program to either avoid the problem or to fix the problem, or use some kinds of like a compromised solution. The bottom line it is, in the action phase, you try your best to get the planned action uh, happen and report errors and collect the information and get prepared to the next phase of observation and enter next loop of this observation, thinking, action loops. In summary, this observation, think, and action paradigm is pretty common in robotics programming. Um, we will get more experience in this paradigm in each individual projects.